All right, let's start on example number 3. I've invested $10,000 in a bank account that earns 5.6%. Now, here is where I'm going to start being very careful. Compounded monthly, so I'm going to look after that over 4 years. What is the investment at the maturity? So again, we're talking about what is the future value. So that's what I want to compute. So that's what I'm going to be calculating in my calculator. So let me move on. Haley has invested $10,000. So presently, she has given away, not given, but invested away $10,000. She earns 5.6% interest. The regular amount of payments, the amount of regular payments is $0, so you just put 0. My future I'm going to leave as it is. Since my payments per year, since my payments are 0, I'm going to put as 1. My compounding per year, well, it's compounded monthly. How many months are in a year? 12. So the CY is 12. Now all the way up here, N. N is PY, payments per year. Now here it's 1 times the number of years is 4. So let's type that into the calculator, see what it spits out. So now I've done something a little bit different. I've entered my information as needed. So you know what I really don't like? I really don't like when my future value already has a number. I want to avoid confusion. So what I did was enter a bunch of 9s before I hit the calculation button. So I inputted N, I, PV, payment, P over Y, and C over Y. And now I'm going to calculate my future value. If I calculate my future value, what we see is that it's $12,504.19. So I copy down my answer for example number 3. And what we notice, if we go to example number 2, example number 3 and example number 2 were kind of very interesting questions because we both invested the same amount. We both earned an interest rate of 5.6. However, the amount that it was compounded, the number of times and really what compounded means is interest is added. How often is interest added? Well, it shouldn't be as a surprise, even though that we're getting paid the same amount of interest per year. The more frequent compounding occurs, the larger the amount that you'll get. So you will earn more money if the compounding period is increased. So let's move on to the next part. I've skipped to example number 5. Example number 4 was very similar to what we've previously discussed. Example number 5 differs slightly. So a bank offers an interest of 6.5%. So I'm going to per annum. So PA must stand per annum. It is compounded monthly. Okay? How many years? So how many years will it take for the investment of $10,000 to be worth $1,200? So this question feels a little bit different. Number one, it's less writing for sure, but it's also changing what is being asked. Here, how many years will it take? So how many years will it take? I guess what we want is some sort of measure of this, right? And remember, N is PY times Y. So let me put this in and try to get a handle on it. My interest rate is 6.5% per annum. So I'm just going to put 6.5. My present value, it would be this one. I initially invest $1,000, so my present value is $1,000. I'm still not making regular monthly payments. That's not a part of the question, and whenever that happens, automatically P over Y is 1. How many years will it take for my present value to be worth $1,200. So this would be my future value. Now my future value should be positive. And the reason why I say that is because this will be how much it'll be worth in the future. Let's not forget CY. I like highlighting because CY, it's compounded. Well, it's compounded monthly, so 12. So right now is how many years will this take? I have all the information. I'm going to use my calculator to calculate N. So now I simply input all of my relevant data. And what I'm going to do now is I'm simply going to calculate N. If you notice I put a bunch of 9s, that's my own thing because I want to figure it out and I don't want to make a transcription error or take anything for granted. So I'm going to hit solve, and what I get is 2.81253 years. So I'm going to write that down. So now that I've written it down, it takes 2.8125 years. And good sources have told me we are always going to round to or keep at least 2 decimal places. All right, let's go on to the next question. How much must be invested? Okay, I'm going to take a highlighter because I like doing that. How much must be invested in order to have $15,000 in 6 years at an interest rate that much per annum? So I'm going to press pause, and I would like you to sort of figure out, fill in the table, what are we doing here? Okay. So how much must be invested in order to have? So in the future, we need to have $15,000, so that'll be my future value. So how much must we have invested? That speaks to what is my present value. So my present value, this is what I'm being asked to calculate in 6 years. Now keep in mind, N is P, payments per year, times years. So since it's automatically 1, the amount of years is 6. 1 times 6 is 6. So let us calculate this in our calculator to see what that looks like. So really, this is what I would like to calculate. N is 6, I is 6.25. My payment, I'm going to make 0. My future value, I would like $15,000. Payments per year is 1. And my times that is compounded, since it's compounded weekly, there's 52 weeks in a year. There it is. So this is the amount that I would like to calculate, is my present value. So simply hit alpha, solve, and what I get is that I need to invest, pardon me, I made a small transcription error, it's right here, 6.25. So let's see if that changes the answer, I wonder. Look at that. I need to invest today $10,311.66. So allow me to write that down here. So I need to invest so the amount invested will have to be $10,311.669. We're going to round it to 2 decimal places. There we have it. I hope this has been helpful. If you have any questions, feel free to ask.